Hi, fifth period Algebra 2, and anybody else who might want to be checking this out. Yesterday we had some technical difficulties in class and we're unable to finish our notes, so I just wanted to do a quick video finishing them. Some of you got to see problems C and D, so if you don't need to see those again, you can fast forward the video and just watch the part where I go over E and F. So if you needed C, we'll go ahead and start here. We're finding the solution of this system of equations. So we're going to look at where these lines intersect to find that solution. So our first equation is the line x equals 4, which is a vertical line. It's the vertical line where all the x values are 4. And then the other line is not in slope-intercept form. So we want to do that first. We want to get y by itself. So I'm going to add 2y to both sides to get x equals 14 plus 2y. And right now, x is by itself. We want y by itself, so we're going to subtract 14 from both sides. And x and 14 aren't like terms, so we're going to write them side by side. And we get x minus 14 equals 0 plus 2y. Then we're going to divide each term by 2 so that we can get it in slope-intercept form. And then if we rewrite that, it would be y equals, because the 2 divided by 2 is 1, so 1y, so y equals 1/2 x minus 7. You want to write that as 1/2 x instead of x over 2 because the coefficient of x, the number in front of x, is your slope, and x divided by 2 is the same as 1/2 times x. So this is your slope, rise over run, and then your y-intercept is the point 0, negative 7. So we're going to go over to our graph. We're going to start at the y-intercept, which is the point 0, negative 7, and our slope is positive. So to make our line rise from left to right and have a positive slope, we can either go up 1 and to the right 2 to get our points, or we can go down 1 and to the left 2 to get points. So remember, when you're doing your slope, you can get points in both directions, okay? So now draw a line through those points. Put your arrows on the end to show that it's a line, not a line segment. And then where they intersect, that is your solution. That is the point that is common to both of them, so it is the solution of your system. So this is the point 4, negative 5. Okay, the next one, the first equation is in slope-intercept form, so we can go ahead and graph it. Our y-intercept is negative 4, and our slope is negative 1/2. So we want our line to fall from left to right. So with a rise and run of 1 and 2, to make it fall from left to right, we can go down 1 and to the right 2 to get points, or we can go up 1 and to the left 2 to get points. And that will make a line that is falling, which is what a negative slope line looks like. Once you get points all the way across your graph, then go ahead and draw the line that goes through those points. Put arrows on the end. Now let's take a look at our other line. Our other line is in standard form, so first we want to get it in slope-intercept form. So I'm going to subtract 3x from both sides. And that would be 0 plus 6y. So that's 6y equals negative 12 minus 3x. Then we're going to divide every term by 6 to get y by itself. And then I'm going to rearrange it so it's in slope-intercept form. So 6 divided by 6 is 1. That's what we want, 1y equals, and then we've got negative 2 minus 1/2 x. And I'm going to go ahead and switch those around and write it as negative 1/2 x minus 2. Here's my slope, and then my y-intercept is the point 0, negative 2. So go to the point 0, -2, and then the slope is negative, so my line's going to fall from left to right, and probably about now you're noticing, hold on a minute, isn't that the slope of the other one? And it is. So this is going to be an example of parallel lines. And parallel lines never intersect, so therefore there is no solution for this system. There's no point they have in common. So for this one, you're going to write no solution. Alrighty, so that's the rest of the notes on the graphing systems of equations. And then now we just wanted to show you a little trick here when you have some equations that are maybe difficult for you to solve algebraically. A lot of times kids don't like to solve these type of equations algebraically with the fractions. So a way you can do this is you can take each side of your equation and make it into slope-intercept form. So just set each side of the equation equal to y. So y equals 4x plus 9. And then take the other side of the equation, set it equal to y. Y equals 1/4 x minus 6. And then when you graph those two equations, watch what happens. This is super cool. So if we graph the one on the left, 4x plus 9, that's a y-intercept of 9 and a slope of 4. So a positive slope of 4 means your line is going to rise from left to right. So I don't have enough room to go up, so I'm going to go down 4. Here, I'll get a highlighter here. Go down 4 and to the left 1. And then do that a few more times. Down 4 to the left 1. And I'm just going to go all the way across my graph because I'm not sure where it'll intersect. And that's about as far as I can go. So then I'll draw the line that goes through those points. Didn't do a very good job on that first attempt. Oh boy, having some bad luck here. One more time, third time's a charm. There we go. And then our other line is 1/4 x minus 6, so that's a y-intercept of -6. And then a slope of 1/4, so that's a positive slope also. So I want my line to rise from left to right, so I can either go down 1 and to the right 4, which is our intersection point, or I can go up 1 and to the left 4 to get a few more points. And then draw the line that goes through those points. Well, I'm sorry, it's a little bit off, but you guys can see what it is. So the solution then is the point -4, -5. Now, that's the solution to a system of equations, but this wasn't a system of equations. We just wanted to know what x was, but we used a system of equations to find it. So when we look at the intersection point, we just want the x value of it. So our solution is actually just x equals 4. Because this wasn't a system of equations, we just used the system of equations technique to solve it. And just to show you even better, I'll go ahead and do solve it algebraically. So solving it algebraically, 4x plus 9 equals 1/4 x minus 6. So this is the same equation but solved graphically. So since I have a fraction, I'm going to get rid of that fraction by multiplying everything by the denominator. So if I multiply every term by 4, then I would get the equation 4 times 4x, 16x. 4 times 9, 36. 4 times 1/4 x would be 1x. And 4 times minus 6 would be minus 24. Then from there, I see that I have variables on both sides, so I would subtract 1x from both sides. And I would get 15x plus 36 equals negative 24. And then I would subtract 36 from both sides to get 15x equals negative 60. And divide both sides by 15 to get x equals negative 4. So solving it algebraically, I get x equals negative 4. Solving it graphically, I get an intersection point with an x coordinate of negative 4. It's just another way to do it. Now, I'm going to run out of time here with my next class, but at least let me get you started here in this next one. This next one, what you would do is you would set this side, if you're going to do it graphically, you would graph the line y equals negative 9/5 x minus 10. And then you would graph the horizontal line y equals 8. So when you graph those two lines, where they intersect, that's going to be the x coordinate of that intersection will be your solution. And then you can check it graphically. And if you get stuck on this one, since I don't have time to go through the whole thing, you can go ahead and look at my answer key next week, okay? Or if you message me, I'll make another video of just problem F, okay? Hopefully that helps. Sorry about all the technical difficulties yesterday, and I hope you have a great weekend. Okay, bye guys.